Go.
Hello.
Hello, Mr. Harry, Mr. Ryan, are you alright?
Yeah.
What's graph? We talk about graph all the time. What's graph?
A graph is a graph.
Okay, now a graph is a graph, yeah. But it's a collection of vertex E
Edges.
edges.
I
Vertex
got vertex, you got edges.
The tree.
Yeah.
Is tree a graph?
Like,
It's tree.
Yes.
Yes. It's
I got tree and you got nothing.
okay. So if there are two trees, what do we call it?
Forest.
Forest. Yeah. It's also yeah.
No, forest.
A tree is a connected. Come on. A tree
Free.
is a connected. Yeah, single component connected. No cycles. Yeah, no cycles.
Circles are too
Yeah.
boring.
You know the simple graph. Another concept. Simple graph. What's simple graph?
Simple graph.
Is that okay? So you can't have these. You can't have two edges between two. Right?
Yes.
Yeah. Yeah. This is not a simple graph. Okay. Okay.
It looks like a car.
Yeah. I know. Okay.
Now it looks like a
This is not simple graph, but
Okay.
this is okay. This is a simple graph. Okay.
It looks like a
Yeah.
robot. It looks like a unicycle.
Okay, so the trees, come on, the trees are directed, DAG, yeah? What's DAG? This is a few concepts we need to review.
Dag.
What's DAG?
DAG is directed acyclic graph.
Okay, so it has direction, yeah? It has direction. And a cyclic means there's no cycle, right?
But
Okay.
I did.
Okay, so let's say,
But if
A.
you see,
come on.
if I tell you, you'll say at the same time as me.
Okay, so this is a graph, okay? This is a graph.
I didn't get that. You were saying it. I got this.
Yeah, this is a graph. A,
I got this
Come on.
little bit.
A,
No.
A means a task. Yeah, these are the tasks. A means you need to play piano, okay?
Oh.
B means you need to do the homework,
Oh.
okay? Oh no, C is doing homework, and then D is like you can play games,
Yay!
okay? And then D is like you need to go to sleep, okay?
Oh. I'll just read my puzzle book.
Okay. So how many tasks do you need to have to do first before you go to visit all the notes in the graph
You have to do piano and homework first.
and
then you have to
homework first, yeah.
and
So
then you have
so at
to
the
play
beginning,
games, and
yeah,
then
yeah.
you have to go to sleep.
Yeah. Okay. So look, in order to visit all the nodes in the graph, we have to visit A and C. These two can be done in parallel. Yeah, playing piano and doing homework. Okay. Okay. So we call this kind of traversal, the graph. We call it topology. You know what's topology?
Topology is topology.
Topology.
It's topology.
This can be visualized as dependency. Yeah? In order to do the B, you have to do the A and C first. Yeah? A and C are independent. You can do it in parallel, right? Okay, so today's task very simple. Given the graph, with directions, find out the number of the nodes minimum number of nodes we have to visit in order to visit all the nodes in the graph. Make sense? For example, the A and C, this is the minimum number of nodes we can start doing in order to finish all the visiting all the other nodes, right? Yeah? Am I clear?
Yes.
Am I clear? Yeah? So for example, another one, you tell me, okay? Okay, this is a bit tricky. Okay. This is a bit tricky, okay?
Is it or is it not?
Okay, so look, here's a cycle, yeah? Or maybe here's a cycle, okay?
Wow.
Well, this is a bit tricky, yeah? Well, D, obviously, we need to do it first. But how about this A, B, C? Look, in order to A, you need to finish C, right? But in order to finish C, you need to finish B. So there's a cycle, right?
You can't do anything.
Yeah, that's a good question. Okay, so let's
Then
assume
after
that.
doing piano, you could play games. And after doing play games, you could do homework. And then
Okay.
after homework, you do
Okay. What?
Topologic.
Topological. Okay, so look, there's a cycle, yeah? This cycle, look, this is a cycle. a triangle. A triangle. A, B, C. In order to do B, you need to finish A. In order to do C, you need to finish B. Okay. In order to, yeah, this is a cycle, so you can't finish it, right? Okay, so let's assume there is no cycle. Let's not assume there's no cycle. D,
D,
A,
A, B,
D.
C. D,
Okay,
A,
how
B,
about
C.
this?
D.
Just D, yeah? Yeah?
D, A, B, C.
Make sense?
Yeah.
Okay, so we can start with D first, right? That's the minimum number of the notes. You can start at first, okay?
And then B, then C, then go to sleep, play piano, play games.
No. This is different class. Different class.
And do homework at the end. Yay!
What's your idea? Looking at the graph, what's our approach to find the notes that we can start at first?
The thing is, it's
We need to check what?
Wait. We need to check if something points to it.
Yeah, exactly. Something points to it. You bring a very good concept. What do we call it? Something points to it. In
Middle.
degree. Okay, we have two concepts. In. Okay, in. Yeah, this is in. This is out. Okay, make sense? Yeah. Going out of the edge is go out. Degree means the number. Yeah. How many? Look, we can count. How many? Look, this B. How many edges coming to it? Going into it.
2.
So the in degree is 2. How many edges coming out of B? 1. So our degree is 1. Right? Yeah. So we just have to collect all the nodes which has the in degree equals to what?
If it has in degree 0.
That's the way down. Let's say if in degree is 0, then that's the node we can start. Right? Make sense? Yeah. Look, in degree 0, AC. The in degree 2, in degree what? D. What's the in degree?
In degree D is 1.
What's the out degree of B?
1.
What's the out degree of D?
0.
What's the out degree A and C?
1.
Well done. Good job. Okay, that's it for today. Easy. Let's write the code and I'll be.
So that's it for the day. Let's just write the code and that'll be it. Right?
In degree, out
we need
degree.
to go.
Okay, that's very important concept of topology. Topology sorting
No, it
of a
isn't
graph.
topology, it's topologic.
Okay, you're just making up the words, okay?
It is actually topologic. Yeah. Topology.
Define, let's say,
over O.
find node, okay? Then we have given what? Let's get edges, okay? Let's given the edges. I know. Edges A to B, okay? Let's put all the nodes in the set. Okay? Let's say nodes equals a set. Alright? And then we just need to go from A to B, yeah? Edges from A to B, yeah? In edges. Then nodes dot add. We're adding this node A, and then we also need to add what? Huh? We add the A, we also need to add the B, yeah? Okay, and then now look. So we have we need to have a data structure to store the number of to count how many edges pointing in, yeah? Yeah? Okay. So let's say G equals default dictionary, alright? What's default dictionary?
You're just getting a dictionary.
Okay. The type of default is in 0 int, okay? So then G plus equal 1. Okay, GA or GB, come on. We want to count the in degree. GB, yeah. A to B, so it's GB, okay. You write that, okay? And then now this answer, we have this node, yeah? Answer equals set, in the list. Then we go through all the nodes, yeah? N in nodes. This is all the nodes. And then what should we do with that? How do we check? If G N equal what?
0.
0. Then what should we do with it? Answer dot what? Put it in the answer. Append. N. And then return answer.
Yeah.
What's the times complexity?
Uh,
The number of edges, let's say N, okay? N is the number of edges. Go through the edges.
N.
On, yeah. What's the space complexity? Huh? What's the space complexity? Here, G and no. On. Yeah, make sense?
Yeah.
Okay, that's it for today. Good job. It's quite easy today, yeah, isn't it? You see, this topology sorting is topology, yeah.
Topological.
Is that we given a graph with dependency with the directions. It mainly refers to the DAG, directed. Yeah. A pointed to B means that in order to finish B, to complete B, you have to do A first. Yeah. For example, the task. Yeah. Finish homework, do and playing game. Right.
Yeah.
And then today we talk about the in degree, out degree. In degree is the number of edges pointing to that vertex. Out degree is number of edges going out of the degree. Okay. And what should we do? What are we doing here? Like first of all, we calculate this in degree, and then we just append the note with in degree equals 0. Means that there's no task depending on that vertex, right? Yeah, simple, right? That's it for today. Bye bye.
Bye.